All right, cool. Um, yeah, again, welcome back. Today, today I'm not sure I'm going to keep doing the same thing we've been doing this entire time. So we're now on the ninth week of this, which I'm very proud of and pretty excited about. But I was thinking about this over the weekend, and I got kind of frustrated actually because I've just been working on basically a Makefile for like 8 or 9 weeks now. And I've learned a lot and it has been enjoyable, but I was thinking more and more deeply about the work I'm doing. And more I have the sense that it just doesn't make sense to be investing so much effort into the build system anymore, because I've been working really hard to implement things like out of tree builds and yeah, just like all these very basic and fundamental build system things. And it's producing an extremely messy Makefile. And I just don't really see that as a sustainable way forward long term. It's just way too error prone and low level. So I'm actually very strongly considering porting things to CMake, which is something I was kind of averse to doing in the past. I was pretty against the idea of porting to CMake. And my reasoning was because I was very new to the code base. Let me just drag in some editor files and stuff like that. I was very new to this code base, and I was really concerned that if I dove right into rewriting the build system from scratch, that it would be introducing too many things at once for me. And that would just lead to failure, basically. I'm just gonna put. I also want to check one thing in the chat that I have. I have these like stream chat pop-ups now. Hello, hello. And I wonder if they actually appear. It looks like it did. Hello, hello. Nice. You know what? I'm going to also put a Discord chat share link in here just in case people want to join. Copy. Yeah, maybe I'll edit my description too. Yeah, but anyway, yeah, at that time I was very concerned about not having enough knowledge of the code base to take on something like rewriting it fully from scratch in CMake. And rather, I wanted to build some experience with it by just working and making small improvements to the existing Makefile-based build system. And it's safe to say that I've really done this, because we're now in week 9. And so for 8 weeks, I was basically just getting very practical experience with how the build system works. And what we're looking at in my editor right now is the current state of the art of how far I've managed to push it in my little 2-hour work sessions. And I'm not happy with it really, because it's just like, look at this, look at these massive chunks of like noisy code. You have to put this build kernel thing everywhere. There's probably ways to improve this. Maybe that variable name is too verbose. Maybe there's other ways to structure this. But the key thing that has changed since when I first started this project is that I have a lot more experience with the build system now. And at this point, I'm actually feeling much more comfortable with it. I have a better understanding of what is actually here. What are the things that don't matter? Also, like, why is this Kemu thing still around? Oh yeah, I think I was just playing around. Um, so in this version of the branch and stuff, we moved all the Kemu emulator stuff into a separate file just to reduce noise. Yo, Lizard, what's up, my dude? Good to see you. Thanks for joining. Yeah, so like last time we did a lot of hard work and moved the stuff out, but I just moved it back in because I kind of want to evaluate, again, from a global perspective, what the build system looks like overall. Because if I want to port things over to CMake, I want to know what I'm getting myself into. And I think another aspect is, yeah, it just, my current interests and curiosities, yeah, I just think working with CMake would be kind of fun, and that would be an area of active learning for me. So kind of feeling that today. There's a lot of stuff I don't know. I don't exactly know. I mean, even in all this time of working on the build system, I had never really touched user space build. I was entirely focused on the kernel build because it was just kind of a lot to understand. And there were also various diversions and stuff like that. But yeah, I think, yeah. Yeah, I'm just trying to think if there's anything else I want to do here. I also want to quickly check on the stream to make sure it's healthy. Yeah, Lizard, you're like interested in that very much. I need to learn about build systems and larger C and C++ projects in general. Nice. Yeah, that's cool that you're interested in that too. CMake, it would be cool to work on CMake and just get some experience with that right here. CMake is definitely the most cutting edge, modern build system for C++, maybe also for C, and it is extremely widely used. And there's a reason a lot of other people use it. Andreas Kling uses it for Serenity OS, for example. But I mean, there are many, many, many projects that use CMake. And so, yeah, compared to other options, I did kind of consider some other options of build systems to use, like there's this one called Scons, which is kind of interesting. It's definitely less commonly used than CMake, but I've also heard it's kind of powerful, but I've also heard people have had bad experiences with it compared to CMake. There are Bazel and Buck, which are these build systems that come out of kind of like Google and Facebook, I think, are like big tech build systems. And yeah, from what I understood, those are meant for kind of massive code bases, and they're better for if you want things like distributed builds and stuff like this. To me, it seems like a bit much for what we're doing. So I chose CMake as the obvious next thing we could try. And yeah. So anyway, that's just one thought. We could do that today. Or we could kind of continue with this route of our development, which is what we've been doing, which was trying to basically do some more Git stuff. So I had this really messy development branch that did a bunch of these build system refactors. Yeah, big tech build systems, yeah. Yeah, I had this really messy development branch. And we have been applying like really professional levels of rigor to the Git history to kind of rewrite the branch and make it extremely reviewable and orderly. And we didn't finish. There is still a pretty big commit That's here, and over time it got a lot smaller, but it's still pretty big. And it would be a little bit of a hassle, I think, to keep proceeding with that. Yeah, I'm not sure. I mean, personally, I'm not feeling that excited about it, really. And also from the perspective of this potential CMake port, it's very questionable if it's time well invested, if eventually we're going to scrap this entire thing. Potentially stupid question, do we really need this? Like, isn't this slowing you down? If you're referring to the Git stuff, which I think you're referring to, yeah, it's a good question. I think the easy answer is like no. A lot of the Git stuff is not necessary. It's definitely optional, and it definitely does slow things down. The reason why I'm doing it is because I actually I enjoy it though. I enjoy using Git and like doing these practices and improving at them. I also think it's good practice. And overall, I would like to still be able to do that, because when you do the Git history thing, you get a lot of benefits from that. You really understand your code a lot better if you go through the full process of not only writing the code and making sure it works, but then also caring about how it looks in the version control history. That might be a bit of a controversial opinion for some people, but in my opinion, in my experience, you do get a lot out of it. And maybe that's not appropriate for all projects. I mean, it definitely isn't. But personally, I kind of enjoy thinking like that. And so, yeah, to the extent that like it doesn't really tank the progress on the whole thing, I want to keep doing it. But it's definitely a good point that it does slow things down a lot. I'm not that concerned about speed of development, really. I'm just trying to have fun every week, but it is definitely a valid point. And I would say, yeah, it's something to be careful of. And that's kind of what we're doing right now. I'm kind of being a little bit wary of it right now. And I think, I would say let's just go for it. Let's play with CMake today. There's no reason not to. So I'm going to go back to the main Garden OS repo. I have these two checkouts because I kind of just like having two, so I can flip back and forth easily. It came in handy last time when we were doing a lot of these refactors. But let's just, again, do a quick check-in on where we are. So now I'm in my main checkout of the repo. I'm in like the main branch that I've been using, and let's just check in and just like make sure things still work. Make Kimu. That's already way too. Why was that so slow? That was such a slow build. Okay, go hi, echo hi. Good. Oops. So we're back at a clean state. I'll just really clean it up. So now I'm going to make a branch called CMake. And yeah, where do we even start with this? We're going to start with a file called CMake lists. Touch CMake lists.txt. CMake lists. Hello. Where'd it go? Why didn't I find it? Oh, I'm in the wrong repo. Okay, good. And here is where I might just ask ChatGPT for a basic, I actually kind of already did ask it a little bit for what it would look like to rewrite this. Yeah. You know, actually, I'm gonna do this another way. I am going to just look up another project that uses CMake and just start copying code from it. That might be a bit more interesting, I think. Yeah. Trying to. So one that I know of off the bat is Wriggle Engine. Yeah. I'm trying to collapse my Chrome window a little bit. Oh, watch Modern Family. That's funny. Yeah. This is just a code base I like a lot. Can you increase the font a bit? Oh, thanks for asking, Glenford. Man, I thought I already increased the font quite a bit. I'm not sure how easy it is for me to keep increasing it more. I already increased my font to like my display to the maximum resolution. It should be the same as last time. For the terminal, thanks. I can pop it up like another level. Yeah, sure. Thanks for asking. Let me know if you want it like a little bit even bigger still, but that's how I have it for now. Yeah, nice to see you again, Glenford, too. Thanks for joining again. So what version of CMake do I even have? 3.27.5. Okay. Yeah, I think I have to like give a big warning up front that this might be kind of chaotic. This is like really just doing things from absolute scratch. Fatal error. But that's kind of part of the fun. Oh. Chaotic good. Huh. Yeah, I don't start off with the 0, 1, 0 for whatever reason. You know what? I'm gonna just. Yeah, I kind of wish. I don't know why my why my browser window is so weird. I think I'm going to quickly switch over to a different Chrome profile just for the stream. Yeah, let's try that. GitHub, Vim and OS. This German stuff. Project Serenity OS. Oh, what? CFlags ASM. Okay. Let me get this back over here so I can see the chat and stuff. Chaotic good. Yeah, so I think I need this C and ASM. I'm not sure about, I should really have the CMake docs open. Let me get that too. I wonder actually, CMake docs. can I wonder if I can make, I cannot make a shortcut here. Okay. Well, whatever. Yeah. So just out of curiosity, project language names, and you can also specify a version. Neat. Okay. So I will get this thing out of the way. Yeah. Okay. So far, this is what we have. I'm still not totally clear why that's relevant. I will open up one more reference, which is a project that I made a long time ago called librequests, which I also wrote in, I also made in CMake. Project librequests. Oops. So yeah. So I think, I don't know how useful Wriggle Engine is going to be because it's not an OS. It's like a normal program. Serenity OS, I mean, it's definitely going to be a very complex build system. But these custom target things are going to be pretty interesting. We're going to need something similar to that. Yeah, and overall, maybe just to map out a little bit of what we're doing, Makefile tools, not right now. Yeah, so we're going to try to port this over to CMake. So we should set a goal of like, yeah, it's going to be kind of piece by piece. The weird thing about an OS is that the build is pretty non-standard, and it's not like a normal application where you just have all these like C files and then you build them and then link them and then you have your executable. It is a little bit like that, but there's extra details like the linker script. Although, actually, maybe this is not actually that exotic. But, yeah. Just thinking about how to begin. Oh, I forgot I'm missing my timeout thing maybe for the 20-second breaks. Okay. Here's what I'm going to do. I'm going to go to ChatGPT again because I've already asked quite a few questions and it gave a bunch of stuff for me. So I'm just going to kind of copy and paste a couple other things that it pasted, or that it gave to me, and we'll see where that goes. So we have a project. This is kind of the important part. We have this tool prefix thing. But I think I'm getting a bit ahead of myself though. I should just set like a kind of a goal of a thing to do. And I'm just gonna open the chat up again. Yeah. Probably for your tool chain. Yeah, that's the tool prefix thing. That's very important because we're using this like, I'm using this like random tool chain that is extremely different from like the native tool chain on my system. So yeah, but back to here. There's a few choices. We can try to build the kernel executable using CMake. That's probably a pretty decent thing to try. And we can make a kernel like target. It has all these dependencies of these other things, like the init code, like the entry other, and entry.o, which was up here, right? Oh yeah, I think it's not even declared. There's just like this entry.s file. Right. And so, and for some reason that is considered separate from the kernel. That's like just like kind of a quick question to understand what this entry thing is. The XV6 kernel starts executing in this file. Right. So we have bootasm.s. And then boot, I believe, so this is the really low level code. That's the bootloader. And then I believe is boot main here? No. Maybe I should read this. The boot block, bootasm.s jumps to entry. Aha, oh interesting. There's bootasm.s, which jumps to bootmain.c. Boot main is not the kernel, it's the bootloader. Okay, so the point of the bootasm.s is to do the absolute basics of booting the CPU, and then the bootasm.s tries to get out of assembly and then into C code as soon as possible, basically. And so we transition to the second stage of the bootloader, which is written in C code, now that that has been made available. And now that we have C code, we can then, read. Apparently disk reading is working. That's kind of interesting. I'm kind of curious how that works. Read sect. It's probably doing some IO, some input-output instructions to talk with the disk controller or something like that. Yeah. So this is still not the kernel yet, but once we've read the kernel off of disk and done some basic loading of it, then we can jump to it and jump to the entry point. So I think maybe I knew all this at one point, but it's been a while since I've had to look at these details. So yeah, I just realized my OBS text is out of date now because we're not doing this old stuff. We're doing the CMake rewrite. Okay, cool. So that's good to know, because like that helps with some orientation here. So now I know that, yeah, entry.o is really part of the kernel. But what is interesting is that for some reason, okay, boot main, so we start in assembly, graduate to C for the bootloader, then call the kernel, and then now we're back in assembly for some reason, probably a good reason. Because now that we're in the kernel, I don't know, we need to like do other things before we can then actually graduate to to C code for the actual kernel, which is here in main.c. which is now we are properly in the kernel in C code and are able to do all this stuff. Yeah. I was just thinking about how, we don't even need to work on this build stuff at all. If we wanted to, we could just start hacking on some C code and not worry about the messy, crazy build system. But let's not switch directions. Let's just for today keep going with this CMake thing, which I think will be worth it. Does going into assembly again take care of enabling certain memory management stuff we need? I'm not sure actually. I don't actually know what you mean by that exactly. Or maybe I think you're asking what is the point of okay, I see. Yeah, what is the point of this assembly code? Is it related to memory management? Okay, I think the answer is like yes. There are specific things. Turn on paging. Yeah, there's just specific things that the bootloader doesn't do for the kernel that are only accessible from assembly and also kind of essential to do early, related to yes, memory management. Turn on page size extension. That is interesting. 4 megabyte pages. I'm actually pretty surprised to see this because I would consider that a bit more advanced or something like that. 4 megabyte pages, usually 4 kilobyte pages is the standard. I actually am not very knowledgeable about this. I believe this is what the Linux kernel calls transparent huge page support. You can just check that. Kernel p size. Okay, no, I'm wrong. The huge page size is 2 megabytes. So x86, what was it, 4 megabyte page? Okay, yeah. Pages extension, feature of x86 allows for pages larger than 4K. This is interesting. PSC allows for page sizes of 4 megabytes to exist along with 4 kilobyte pages. Kernel fragmentation. Okay, we don't need to go crazy deep into this. If PAE is used, the size of large pages is reduced from 4 to 2 megabytes, and PSE is always enabled regardless of the PSE bit. Interesting. I think physical address extension. That's that other thing that exists in x86. I think that's the thing that adds support for the NX bit and stuff like that. It's a bit too detailed for us right now. Also, none of this is relevant for 64-bit. I think, at least I'm pretty confident that this is not very relevant for 64-bit, although maybe it's possible that this still exists in 64-bit. Okay, back to here. So observe this interesting thing. They're opting into these large page sizes. Some paging stuff. I think it's using AT&T assembly syntax, which I always kind of forget. It goes left to right, I think. So loads something into EAX, then EAX into CR3. Oh yeah, and CR3 is the top of the page table structure. So it loads interesting. I wonder, it's including some stuff. Yeah. We can dig into this later. I wonder if it includes some page table entries like kind of that are built at compile time or something. I'm sufficiently curious about that to just grab for that right now. It has an array of PDET. But what? I actually don't really get the syntax. It's like an empty array of PDET, and presumably it gets filled at some point. But this is oh. Start others. But what? I'm in main.c, right? Yeah. So I kind of don't get why this is declared up here. Oh, it's a forward declaration maybe of an array, because it needs to be, that variable needs to be referenced by this code. But it also then, but it actually is populated over here. And yeah, it's kind of what I thought. It's just like constructed at compile time. Where does that variable come from? Also, why? 1024 entries per page directory. Also, what the page size? What? That is kind of weird. Page size 4K, but didn't the boot assembly, or didn't the entry.s set it to 4 megabyte pages, or did I read that wrong? Turn on, yeah. So like, I don't get that really. But yeah, and then so now we have two initial mappings, and they map some like very basic stuff. So yeah, interesting. So yeah, get some basic virtual memory stuff going, basic stack, and then apparently interesting, indirect call is needed for some reason. Produce a PC relative instruction for a direct jump. Weird. Okay. Anyway, it's a little bit of a digression. Yeah, that was all just to say that entry.o definitely belongs with the kernel build target. So let's start writing like the most basic build target ever, and then see where we can go from there. Yeah. I'm just looking again at my chat GPT, which I can ask some stuff too. What do I have here so far? Okay, I'm just gonna copy all this in. Yep. And we'll see what happens. I think I asked it to like just like translate the Makefile into CMake. Oh yeah, one thing that might be tricky is the vectors.gen thing, the vectors.s, which so vectors.s is generated at build time and then advertised as an object file that's needed. So maybe actually the first ultra simple build target we could make is a vectors build target. That just generates that. Yeah. Yeah, I wonder. Okay. Yeah, I think we're going to need some custom commands. Or add custom target. So I'm just copying like a bunch of random stuff into here. Does this variable even exist? No. Yeah, okay, when I asked it to generate a CMake file from the Makefile, it did it extremely literally. Which is not really what we want. Yeah, this is already getting like super messy. I don't know if this is necessary. I don't know if this is necessary. Also, what? Okay. The auto formatting was kind of strange there. Okay. I think I just don't have enough knowledge. I need to learn more about CMake. Custom command. If I search for that. No. Custom command. Or for CMake a custom target. Yeah, I think I'm just lacking a little bit of fundamental knowledge to like really make progress of this well, but I think a custom target is what we need. After a 20-second break. Ugh. Okay. Man, these. Okay, I'm just gonna read the docs for a little bit. Add custom target. Okay, this is bad. Okay. This is immediately not what we want. It's a target that's always out of date and just runs some commands. Add custom command. I think this is closer to what we want. The first signature is for adding a custom command to produce an output. This defines a command to generate specific output files. A target created in the same directory that specifies any. A bunch of options. Options. Nice. Custom commands may be used to generate source files, which is exactly what we want. Add custom command, output, something, command, something. Interesting. Let's try. Yeah, let's just try. But when does that run? Who cares? Okay, this is getting already like quite messy. I kind of want to just comment all this out, but then the weird formatting thing happens, and it puts things all on the same line. That was so weird what just happened. I'm going to save. I'm going to turn this off for a hot second while we just figure this out. But this will be like the absolute most tiny piece of progress possible, which is a nice way to start out. So what's the command? Command is also how, so command, I'm gonna keep that around, but it's gonna be like, so it's gonna be CMake current source dir vectors.pl vectors.s. Okay, that's cool. Verbatim, what does verbatim do? All arguments to the commands will be escaped properly for the build tool. So the invoked command receives each argument unchanged. Escapes is recommended. Okay, I don't know how relevant that is for us right now, but let's try. Let's do our first ever. Oh, what? Oh yeah, you get my old build. So yeah, I'm just gonna call it build 2. No, I'm gonna call it build legacy Makefile. Okay, make dir build CMake dot ignoring. Oh, wait, I'm kind of stupid. Okay. CMake dot, and it's supposed to be doing something right now. Okay, generated the build. And CMake build. Did that do anything? I don't think it did anything. Because it's, yeah, like it didn't do anything because we didn't give it a target, a build target. So let's add a build target. All right, we're just going to, yeah. My main question I'm wondering about is what to do with the kernel. So we have some options. The first option is we can try to make the kernel like an executable, like use the add executable thing in CMake. Or we can try to make a custom target that just uses like random commands to make it. But what's my question? I think add executable is appropriate, even if it's for our kernel, because it is ultimately going to be an elf executable, I think. I could maybe look at other projects to ask, like, to see what they do, but I kind of don't want to do that. I kind of want to figure it out on my own, even though it will take a lot of time. But let's just try. So, for example, I wanted to kind of like reference my old thing, for example. So that's building a library. I think the examples, CMake lists. Okay. So I think that, so theoretically that's kind of it. Add executable. What is it? It's just called kernel or something? Yeah, it's just called kernel. Yeah, I am like very suspicious if that will work. Okay, we got something to happen. What? Oh, wait, okay, I'm kind of, yeah. Again, okay, something's happening. Okay, but now we are on our way to trying to build vectors.s. Oh, yeah, okay, it tried to, yeah, it tried to actually build vectors.s, which is not exactly what I had in mind. I only wanted it, yeah, I only wanted it to run this thing, script, and produce a vectors.s, but I didn't want it to continue further and try to actually compile it, because we're not ready to do that. Like, we don't have any of our like tool prefix or anything set up yet. So yeah, I'm just gonna do some Googling. I just lack like information, or I'm gonna do some chat GPTing rather, because that's probably faster. Okay, question is like, or yeah, CMake. How do you make a build target that is backed by arbitrary command lines and produces a like non-standard build output? Can I search for that? Okay, but we kind of went through this before. Add custom command is what we just did. Add custom target is what I looked at earlier, and it didn't seem like a custom target. Like, that's not what we want, because it's always out of date. Yeah, custom command. No, I think, interesting, custom command, interesting. So we can use this depends thing. Current binary dir. Okay. Add custom, was there, you're saying add custom command seems like it's for a case where you first build an executable that then generates some file. maybe, yeah, yeah, possibly we could, um, build an executable file. Maybe. I mean, I think our current use of it is pretty right. I mean, it actually worked. Like it completely did work right now. Um, so it generated vectors.s. So that's like a very simple first step, which is kind of good actually. So it just went too far, but that's fine. We can keep going. So maybe I can do this. Yeah, I'm just thinking about how I want to do this. Like the next thing to kind of do is to replicate a similar thing over here. Okay, wait a second. So init code? Oops, sorry. Now there's all these dependencies though. I think we kind of need to, or we're never going to compile the kernel, sorry, without these dependencies sorted out. Like the init code. That's kind of the thing. Like I don't know how to do this. Like this is like a very weird thing to be building. I don't think CMake doesn't support. Like this is an extremely custom thing to be building. I think we're going to need another custom command. Let's just try. This is going to, I wish I could say, like, please just run the command and then stop the build. Like, I don't want to, maybe that's what I just should, like, for development purposes, I could do the thing that ChatGPT said. I can make a custom target. Called dev. It's like super temporary, and it's just going to depend on a couple things I want to build. Vectors.s. Does this work? So if I do like a CMake, how do I do a clean? I don't even. Yeah, I'm like not that familiar with CMake. CMake make command to clean builder. What? Oh yeah, like is it really the case that I can do a make clean. You can delete the directory. This is what that's the thing that oh yeah, okay, so that's kind of, as far as I'm aware, idiomatic CMake is like use the tool for everything. I think that worked. I just want to take a look at this Makefile that generated. It's kind of cool. Yeah, it generates this Makefile. Okay. Does this work? No. Does this work? Yes. Yes, that worked. Good. So now we have this like little development target. Rather than making the build system like go too far, even though we're like very much not ready, we can just do this kind of thing where we say, in a much more controlled way, I want just to build these things, and apparently it's just based off of like the file name or something. So yeah. So now let's write another custom command for the init code. And I just want to take one second to pause and just acknowledge how much nicer it is to code in CMake, and it gives you so much more infrastructure. For example, this whole concept of the build directory is already just like comes for free with CMake. And we get these nice variables already that are like variables for the source dir and apparently the build dir or the binary dir or something like that. And those were all variables that we needed to like hand roll earlier. So it's just, yeah, it's immediately a nicer experience. So yeah, that's kind of nice. So here is like, yeah, so now we're getting into some interesting stuff. Where like you need to start manually invoking a bunch of build tools. I'm going to do search CMake how to practice for manually running compiler and other build tools in a custom command. Also, my toolchain tools have a custom prefix to prepend. It's like XV6 elf. What does it tell us? Oh yeah, I guess, yeah. I didn't quite think of this, but of course the dumbest thing and the easiest thing to do would just be to, in the command, specify like the name of the build tool, like i386-elf-gcc. Like that's totally viable. But yeah. When defining custom commands, clearly specify your inputs and outputs to take full advantage of CMake's dependency resolution. That's huge. That's super huge. Yeah. I mean, Make also has dependency resolution, but CMake's is better. I think it's much more rich, as far as I understand. Okay. Right. So you can say the output, and you can say depends. Okay. Okay, nice. A little break. Stand up and stretch. Okay, nice. I'm just noticing, I think it's a bit of a quieter day in terms of stream activities and stuff because of the Easter holiday that a lot of people celebrate or spend time with their families and whatnot. Yep. Okay, so generator expression. That looks complicated. Abstract repeated logic. Handle cross-compilation and toolchain files separately. Yeah, that's probably a more mature thing to do, is use an official toolchain file, but I think I don't want to do that yet. Yeah, I think we will just start off much more simply than that. Is that right? Why is... I wonder if this is supposed to come first. Yeah, I'm not sure that's like... Yeah. This is cool. Yeah, yeah. Yeah, glad you think it's cool. Yeah, it's just kind of, I guess it's a little bit slow going to just start from like raw files like this, but we're definitely making some progress. So we have the prefix, kind of annoying, set all that stuff, and then set these things. I kind of... Zig has this concept where the language itself is used as the dual system. That's interesting. Yeah, I don't know much about Zig, but I know that it has very strong like compile time execution. Yeah, just like very strong compile time features. Is this right? CMake C compiler? Or CMake lang compiler? Or... Yeah. All right. So I'm not sure how this is going to really work. Depends on initcode.s. And then the command is what? It's going to be CMake. Oh, okay. So CMake C compiler, CFlags. That's like this. Okay, I think this is relevant. It's up here. All this stuff. Toolchain setup. Oops, nope. Targets. And I think I got that right. So we need all these random flags for some reason. Yeah. I think it got de-assembler. Where did that come from? Okay, that's apparently kind of new. Okay, I don't actually know what's going on at all. ASFlags is totally independent from common flags. Also, what our divide thing went away. Maybe... CC flag. Let's just be simpler. Yeah, step by step. So the first thing we're going to need to do, let's run the C compiler. And to do that, I think C compiler. I wonder if I can just like test if this works. Like, can I just do like a version or something like that? initcode.s. So now what I just want to see is I want to just try running this custom command. I also think I'm doing this wrong. I feel like there has to be some way to just run a command from the command line. Oops. Run custom command from CMake CLI. Okay, it's saying to do exactly what I've already done. Make a custom target. Okay, yeah. Okay, never mind. I just thought that maybe it was possible to skip this step, but looks like it's not. So I'm going to try it. Yeah, it worked. It worked. We got our version string. So that proves that I can run the compiler. That feels good. So then I'll do, it's a little bit CMake CFlags. No, what? It's kind of annoying that it didn't auto suggest this. All right. Okay. This CFlags. That should be the same. It's this long list, which I guess looks kind of the same to me. Error GDB, wall MD02, no aliasing, and then weird stack protector stuff. I guess technically we did use this in the legacy build. And the cool thing about this work right now is we can do both. I can still use the legacy. Does this work actually? Code? Can I do init code? Yeah. I can still use the legacy build system side by side with the new like baby CMake one and compare. What is actually interesting is that it seems like, oh wait, F no stack protector. So it did engage. Plus okay. And then ChatGPT automatically gave us this thing. And this thing. Nope. F no pi. This is weird. No pi. So we are actually missing something. F no dash pi and then no pi. So I think that was something ChatGPT missed. And so I'm just trying to avoid differences that might cause other problems because we already have so much in flight all at once with redoing the build system. Yeah. CMake flags. Okay. What about the linker? Okay. Next up would be the linker. Yeah, you know what? I'm just going to do this for consistency. This is going to be a dumb question, but how do you set a variable to another variable? Prefix. So like this. I think so, maybe. Here's where I want to also reference those other projects because where's my other Chrome? I just like very embarrassingly like don't really. So it turns out like to use a variable, you always need to have the curly braces, it seems. Yeah. You know, I don't like, yeah. So this is that natively supported? Like, or no, wait, that's just custom, and we manually prepend that and produce this thing, which is actually recognized by CMake. CMake block compiler is like CMake C linker. Is that a variable? No. Okay. For the moment, I'm just going to, command. It's going to be like tool prefix LD. I'm going to do the same thing. I'm going to try to ask for the version and see if that works. What? Did that actually work? I don't. I'm not sure. Tool prefix. What if I mess it up? Does it try to execute some weird thing? Clean. Okay, kind of confused. But also, what does our build there even look like right now? There's nothing in it. What? Quick test. What if I go all the way back here? Yeah. Hello. Hey, Asha. Nice to have you. Thanks for joining the stream. Yeah, we're just doing some CMake. Not sure if you know much about CMake. I don't know much about CMake. Okay. What is going on? Can I make, is there like a verbose? Or not verbose. Yeah, good, okay. Okay, clear problem is that CMake current source dir. Yeah. Okay. Tiny bit of progress. Yeah. I'm just observing how it's kind of messy to be constantly setting things to CMake source dir. My question, yeah, what directory does add custom command execute from by default? That's what we're doing, right? Yep. Current binary directory, yeah. Current binary dir. Working directory. So, okay, so yeah, we're currently, it defaults to the binary directory, which is kind of what we want because we're ultimately producing build output files. It's just kind of annoying that this thing is so like long and cumbersome to type. But yeah, it's a problem for another day, I guess. And yeah, we made some progress. Now we're executing this like random thing that doesn't exist. So that's good. So we can just keep it moving. LD flags is something we need. Yeah, I just curious. So everywhere we use LD, we pass LD flags. Nice. Okay, so that makes me wonder if how I can, yeah, how to, like, if I can set the LD flags globally in a way that's recognized later, but CMake LD flags. Okay. CMake exe linker flags. I'm not sure that's what I want though. Yeah. But let's just start simple. It is interesting though, I'm just seeing these quotes stick around. The quotes are actually used here. I don't know if I want that. I think I don't want that actually. So I'm just, before I just keep going, I think I want to get rid of the quotes. Does it, what happens now? It got rid of the quotes. I think that's better. It looks weird to have these quotes there. Even there. I think I need to get rid of it everywhere. Yeah, okay. Back to linker. Oh, wait a sec. Are there even any custom am I like blind? I'm looking for where linker flags is defined, and all I see is this append. Okay, I don't know. Maybe LD flags is like not really necessary. Okay, 20-second break. Okay. So it's possible that we don't actually need this. Although, I should also set up these reminders. Yeah, I just like them, but they're kind of weird too. So here we can really see the output of what runs, -m, blah, 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 blah. And so one thing that's kind of interesting is there's this variation. Start something -n t. Okay, whatever. It's I don't like totally understand this. It's saying -m, then it runs the linker with -v, greps for this like specific thing, and then uses the first one in order to support FreeBSD. I'm just going to do this. I'm just going to copy this. Okay. LD flags. It's very frustrating that it doesn't like auto-complete that. LD flags. And I just have to type stuff more than I need to. Okay. And then the rest of this. Okay. Yeah. What about this? What? Okay. Show white space. White space. I cannot even see. There's some weird tab thing. Like, oh yeah, Makefiles have very weird tab behavior. And tool prefix. Okay, what's it? I'm just kind of doing the dumbest way to approach this. I mean, yeah, no, it's pretty obvious that we need a variable for the linker because it's going to be used like everywhere. I mean, we should, yeah, no, we should just take care of this now. So here is where we set the paths to stuff. Those are all these like formal, like kind of very formal things that are recognized by CMake. But why did that not? I was trying to like copy all these things at the same time. Okay. And set here, and this is going to be LD. We're just going to do a direct port of the Makefile until I learn a better way. Obj dump. So we're going to set some variables. Prefix. What is this? This, now that I look at it, this is all totally redundant. This is just yeah. Yeah, okay, whatever. Tool prefix. I don't even know if those quotes are necessary. This thing is not necessary. Okay, before I go further, let's just make sure this thing still works. Yeah, check that out. It's like, yeah, it's doing stuff. Our build directory has some stuff going into it now. So now we can say, okay, now I'll just fix this up. LD obj copy dump. Let's just do it. Does this work? Yeah, I think that just actually worked. That's cool. That's very cool. So now we just have our builder. Yeah, out of tree build instantly, unlike the 8 weeks I spent trying to build it earlier. Hey, yeah, man, thank you for sticking along with today's stream, which is like a little bit slow, but it's always nice to get things running. But like, just look at how much nicer the CMake output looks. I'll just do a clean. Also, you get the clean target for free. Although actually, I think that didn't work. That is interesting. That is very interesting. The clean target from what I just observed, the clean target that CMake automatically generates only cleans the things it knows about. Also, what am I doing? This is totally wrong in init code. Output vectors.s output is init code as a single thing. Yeah. Let's remove everything here and start over again. So, cannot load cache. Okay, CMake -- dev, boom. Okay, I was kind of expecting more to happen. Oh, okay, because now, yeah, I was being kind of dumb. Okay, yeah. Target dev, good. And then now all this stuff appears. And then now if we do a clean, it only gets rid of the actual top level thing. But in practice, our command produces like 4 other files, which I will just .d. The .d thing is weird because that's actually produced indirectly by this flag, this MD thing. That's kind of weird. I think I might just exclude that. But the rest of these things, and maybe just to keep it really orderly, in order of them being produced, at first it's like initcode.o, then on the next line it's .out. No, wait, no. Okay, this is right. First initcode.o, then initcode.out, then initcode, and then for some reason initcode.asm. And I actually don't know if this will even work to specify all these outputs. Clean? Yeah, that worked. Check that out. It deleted. I can make the dev rule, which makes everything appear, and then now I can do it a clean, which gets rid of everything that we expressed here. But I'll add a to do. To include this because it's only generated due to CFlags. Okay, nice. So I'll just do that just for fun. So now build, that's building nicely. We can clean it up if we care about that, and that's cool too. If you'll remember from past streams, I actually struggled a lot with this in the previous Makefile build because it was very easy to add things to the build and produce build artifacts, but you need to remember to also keep the clean rules up to date when you do that. And in the Makefile, they're in 2 separate places. You specify your build target in one place, and then you specify the clean rules all the way at the bottom. And I had bugs in my old clean rule where I was forgetting to keep it up to date, and therefore things would not get cleaned up properly because I forgot to add it there. The nice thing about this is that in a lot of cases it automatically takes care of making sure the clean rule is up to date, as long as you've I mean, for regular C programming especially and stuff like that, it automatically does all that stuff for you. This case is a little bit more exotic because we are generating like this very exotic blob of like init code or whatever. But the advantage is that it's all in one place though. That's huge. it's not two separate places we need to keep in sync. It's just one place. So that's cool. And now, yeah, now I'm feeling quite a bit more comfortable with this whole thing actually. Maybe I'll just do it like this for consistency. Output. And yeah, our vectors is working. What next? So we are steadily making our way through this list of dependencies, which is awesome. Entry other, yeah, so the kernel needs all this stuff, and we've started with those. We build the init code, the vectors, the entry other would be the next logical thing to do. And now we are just like super well equipped to do this now that we've gotten our basic like kind of knowledge out of the way. So I'm just going to entry other, and it's going to be kind of similar, I think. Yeah, I'm going to put the dependency up at the start. I think that's a bit cleaner. Depends. Maybe even at the top. No. Second after. I think it's cleaner to be like, okay, this is the thing. It produces this thing, but it requires this thing. Here's how to do it. That makes more sense to me. Okay. Entry other, which means entry other.s. And now we are going to copy, I mean, it's basically just this. It's no fpic, no std inc -i c and entry other. If we want it to be even like cuter or whatever, we could even make a variable maybe that just has this thing, so we don't need to type that twice. But yeah, I don't know if I care that much, although it would be kind of nice. Then I would make the variable like here in the global scope or something. Yeah, I'm not going to worry about that now. Let's just keep it moving. NE start text hex 7000 instead of 0. And it's going to be called boot block other.o, right? Wait a sec. No, this is kind of produces entry other.o. Then we call this boot block other.o. Weird. Okay, I don't. Okay. I don't actually don't get this naming at all. We start with entry other.s, compile it into entry other.o, and then produce boot block other.o. Yeah, whatever. I'm not going to question. I'm just going to follow what it says. Tree other.o. Now we have our obj copy. For some reason, block other.o produces entry other. Other.o entry other.asm. Okay, let's try this. Entry other. Okay, did not work. Why did that not work? The linker. failed. Entry other. And what is different? Make elf ld m if86 ne start text. Oh, I have too many that was kind of strange. Too many zeros. Yeah, nice. Entry other right there. Yeah, thanks. Copy paste issue. And then we'll do a clean and just see what's left behind, which is like everything. So we're going to need to do a very similar thing. Okay, what is it? It's you know, what I'm going to do is I'm going to put this first. So there's like for the custom command, there's like a primary output. Then there's all these secondary outputs that are not actually, that we don't actually care about too much. So entry other.o, boot block other.o, entry other, asm. I think that's it. So dev, oh, oops, circular dependency. Yeah, okay, too many. Okay. CMake. Yeah, CMake build. Blah, blah, blah. Build. And it built. And then clean. And the .d thing. Yeah, that's kind of dumb. Okay. Put that last. Ooh, C above. Okay. Yeah, this is like sweet. We're making such good progress. And that was kind of the last thing we needed, actually. And now we're kind of getting ready to make the kernel. We have all the dependencies. But, wait a sec, but, okay. I think we still, I think it still needs to be a custom command. It would have been convenient to do this add executable thing, but I think that's just, I think we need more control than add executable gives us. I think add executable just like is some kind of like canned generic compile command line, but we need all these custom stuff. Be back in 20 seconds. Okay. About 15 minutes left in the stream. I would love to be able to reach some kind of like conclusion here. Okay. Depends. This is tricky. This is different now. Because I wonder what now what do I do? It's like I understand how to invoke all this stuff, but I need to generate all these object files. And there's all these dependencies. Thank you for the heart, if someone just sent a heart. What to do? How do we make these object files? Maybe. Oh, thanks, Jose. Yeah. Okay, I am wondering how to do this. I need to have a bunch of object files. What do I even pass to ChatGPT? Okay, time to think. I could, like the dumbest thing is to manually do all the compile command lines for all these object files, which is not good. How do I maybe... Okay, what's the question I need to ask? I'm just gonna ask ChatGPT a very poorly worded question. Have a custom command for building my kernel executable. It is a linker command that takes in a bunch of object files. How can I use CMake to convert my source files to object files in a custom command? Or should I maybe use add executable or add library instead? Question mark? And yeah, I do not know what to do. Interesting. I can set the link flags. That could be good. Okay, I didn't really read all of that. I will go this route, add executable, and pass it a massive list of source files. So, for example, what? Okay. I don't know, maybe this will work. Okay, bunch of assembly. Then we have like a bunch of C files. Okay, I just tried to do it and yeah, no, that didn't work. I need to like, I just used the Vim copy paste thing, but I'm going in between. Yeah, in between. I need to, what's the fastest way to get rid of that, end thing? Okay. This is funny. This is like this obnoxiously long thing. Okay. add executable source files, set properties. So I'm going to copy paste this. Yeah, I don't know. Okay. Kernel properties link flags, my linker flags, which are I will answer that in 1 second. LD flags. Is that right? No, I need way more flags. I need like all these flags. I need like hella flags. I need like all these. I truly have no idea what kind of command it's going to construct when I do this. I'm just going to like put all these flags. I wonder, does it automatically just... We'll see. Okay. I think that is approximately what replicating this first and most important line. Let's just YOLO. So I have an add executable kernel. So now we're gonna try it. What happens if I do this? Okay. Set target properties called with wrong number of arguments. So maybe this whole thing needs to be in quotes. Ooh. That is so slow. That is insanely slow. Why is it taking like 10 seconds to compile? What is going on? Why is that so slow? What's it doing? What the hell? Yeah, this is bad. I don't know what yeah, this is bad. Make clean, make kernel. What happens under normal situations? Okay. I forgot how to search in a tmux pane. Entry.s. Oh. Right. Actually, I don't know. I just remembered that I had to do one thing in that other branch to make this work. Okay, to quickly answer that question, how do you do that in Vim? Last time I had to make a macro. So what I'm doing, well, first off, like VS Code is like more featureful than Vim, and in particular, I was just doing the if you select anything and then do Command D, it just like keeps going, and I use that all the time. I think that's huge. I don't even know if Vim supports that, and I find that a massive like downside of Vim is like the lack of that feature. Okay, this is like super wrong. Entry.s. I think yeah, this is like wrecked. Entry. Yeah, this is the stuff I was doing last time. I was running the compiler with these special flags. I'm going to ask ChatGPT, like, how do I make Okay, I have some .s assembly files. I want all .s files to be compiled in a specific custom way. With a custom compilation command. How do I do this so that add executable uses my custom command? I don't know yeah. Set source file properties. Okay, show me. Oh, what the hell? Sets source file properties. That's interesting. Let's do it. Yeah, who cares? Okay, find all assembly files. True. For each SM file in this thing. Okay, yeah, what? But that's not quite what I want. Properties. It's not just custom flags. Like I actually, I kind of wonder what would happen if I tried to run this right now. Yeah, it just it just ran the same tool, but allowed me to provide some flags, and that's not what I want. Want to run an entirely different build tool, actually. It defaults to running the AS assembler, but I actually want to run GCC. Explicitly. This is wild. Holy crap. What? Custom command. This is, yeah, I don't know. This is not looking very good. This is kind of why I wanted to avoid CMake from the start, actually, because one advantage of the Makefile is that it's just so simple to do what you want to do. You just type the commands you want to run. And I'm kind of unclear how to convert that right now, because this yeah, how do I yeah, not too sure. I will spend a couple more minutes looking into it, and then we'll end the stream. But yeah, that is a little bit puzzling. There's got to be some way to do this. And I could try Googling for how to do this. I'm also considering Googling if anybody else has ported XV6 to CMake and seeing what they did. But One thing I'm just kind of wondering about though is make clean, make entry.o, for example. How does the build system know to use GCC for this? Because usually it's pretty strange, or maybe I already looked this up. I had like my GNU Makefile. Oh wow, how do I just go to the link source? Yeah. Yeah. Okay. .s. Okay. Okay, I don't, this like doesn't really make sense. It's saying if you have a .s capital, it first runs the preprocessor to produce the lowercase s, then it runs the assembler on that to produce the .o, which is not what I'm seeing here, where somehow it knows to run the GCC. Or maybe that is somehow just registered as the assembler, but I don't think so, because like usually it's .as or -as. So that leads me to think that there is some place that explicitly specifies this. Oh wait, is this AS? No, that's not it. Is there anywhere else that says GCC? No, there's not a lot of mentions of GCC. About CC. Again, I'm not seeing it. So yeah, this is kind of odd. Yeah, interesting. This is actually something that's a lot harder in CMake than in Make. Like in Make, it's very easy to just declare these rules for how one thing gets converted into something else, and then you do whatever you would like to. But that power is also annoying and kind of low level. But my goal was just to take all, like I'm having difficulty compiling assembly files because like way too, like what is actually happening? Why that command just hangs forever? If I just run that command, bash, it just hangs to 20 seconds. Okay, let me get back to my chat window just in case. Okay, but back to this. What I want to do now, so that is like not working. But what I can do is try to figure out what is the most minimal version of this command line that actually does work. Yo, what's up? Is it Damie or Demi? It's all right. I was actually coming to the end of the stream, but I was hopefully trying to just nail one last thing where we are rewriting the OS in CMake, or rewriting the build system in CMake. Oh wait, what? This ARM64 thing is so obviously wrong. and I made a lot of progress. But this didn't work. Why are there semicolons everywhere? CMake disable semicolons args. It's weird, very weird. For some reason, for some reason it knows. Maybe is there something inside entry.s that like tells it to use GCC or something? That would be wild. Stack size, comment. I don't know what that is. Is it the start? No, but if that was the case, then CMake should automatically see this too. So I don't think that's the reason. Oh, I suck at timing. No worries. I'm here every week at the same time. This is towards the end of my slot, but I stream for about 2 hours. So yeah. Just found your stream. If I ask if it's a Unix-based OS or something else, yeah. And just to be clear, I'm actually just hacking on this open source OS that like already existed. I didn't write this from scratch. This is actually this XV6 OS, which is from MIT, and anyone can download it. So it's a Unix-based. I mean, it is a kind of like a re-implementation of actually the original like V6 Unix. So yeah, definitely Unix-based. So yeah, I don't know what is happening. I'm just trying to build my entry.s, and for whatever reason, this like completely hangs. Yeah, also this like little cool thing where CMake automatically puts the object files like in certain paths and stuff. That's very nice. I was hand rolling all of that myself with the previous Makefile build system, which just like sucked so much. I think there's a massive problem with all these with like all these semicolons. I will try to figure that out. I don't actually know the easiest way to do that. Can I fish shell edit CLI in Vim? Press I know it was like, I've definitely done this before, I just don't know. Okay. Alt E and Alt V, is that right? No? Alt V? Nope. Okay. Yeah, no, it feels so dumb to be doing this, but let's just try. So I don't know why there's all these semicolons there. Doesn't really sound right to me. But so many things are so clearly wrong. Like, it should not. So it doesn't know that we're using a custom tool train. That's the problem. It thinks we're like building a Mac app or something like that, which is so wrong. Okay, so that at least that did not. Tadic. What? Okay. Okay. I was just trying to search in this command line, which didn't work. Sorry, just my chat somewhere. There it is. Yeah. All right. This smiley looks so passive aggressive. You mean you're smiling? Semicolon's not looking good. Yeah, they're looking bad. They're looking very bad. What is yeah, like this is just wrong. This dash, it's the assembler. I'm guessing. What? Dash S ignored? Okay. It's looking bad. Why? I think the actual question is, okay. I'm running CMake on Mac. I have an add executable. It by default adds a lot of Mac specific CLI flags, e.g. to Mac OS SDK, which I don't want because I actually want to use a completely isolated tool chain for cross compiling to a separate system. Like, I don't know. How can I fix this? Yeah, it's like it's big problems that that CMake doesn't actually know that that things should be very isolated and not to use the regular system, at least for a lot of stuff. Important for avoid. Oh, so this thing was important. This thing that I. Also, what the hell? From testing the compiler. That's weird. Okay. Interesting. This root. So maybe I'm kind of curious about this, and I do need to get going shortly, but it's kind of hard to stop when we're so far deep into this. Wow. I don't want any of this. Generic elf. Yeah, what about that? So I set this high up here. What about this? Yeah, does it? What happens? I'm just going to delete everything and start over. Okay. Kernel. Oops, kernel. Nope. That literally did nothing. I think it did nothing. It is still injecting a bunch of like junk that I don't CMake system name. Nope, that didn't fix it either. For some reason, it just, there's all this junk there. Why would it be common flags? What if I put quote? No, wait a second, I'm getting kind of lost. Okay. It was here. But yeah, no, my custom flags, which is here. So that, but it's also automatically putting a bunch of other stuff. in there. Yeah. What did this say again? Maybe the toolchain file really is needed. No. Yeah, that's weird. I don't know. Yeah. But I think I'm going to stop for today, even though didn't figure this out, but it was a good session otherwise, and we made a lot of progress and got our CMake build started, which feels pretty good. So I'm going to end the stream here, but thanks a lot for joining, and I will see you next time. See ya. Bye.